Okay, we'll make a start now. I don't want to waste everyone's time. I know that I moved it last minute only because I had another call come up very, out the blue, so I didn't have time to prepare. So I appreciate everyone attending now. Um, I try, we have had a couple of disturbances to the schedule over the past couple of weeks, but it's mostly work related and they can't be avoided. So I'm glad that everyone is okay with swapping it around and things. So last Saturday we talked about our models and how they were struggling to basically determine between slight, serious, and fatal outcomes. And that is number one. It seems to be it's a very unbalanced data set. So there's a lot of noise in favour for slight accidents. So the next sort of step was to figure out if we could build a binary classification model between serious and fatal, just to see if a model would be able to differentiate the two. And hopefully, I don't think Michael's here because Michael was going to work on it as well. I believe you always you had a look at it and recorded some preliminary results into the Slack. We'll take a look at that in a moment. But for people who weren't here on Saturday, the issue that we have is that if the model doesn't perform very well differentiating between the three classes when they're unbalanced, it seemed to work very well when we use SMOTE. Michael used SMOTE, and it seemed to produce fantastic results. But then when it was validated on the validation set, it fell down, and that says to me it's not being it's a problem with the unbalancing as well. But it's not learning the patterns in between each different class. Now, that might simply be because that between the serious and fatal incidents, the data in between them seems to be quite random. There might not be a particular recipe which would indicate whether it's going to be serious or whether it's going to be fatal. Now, the data that I've provided is from the Department of Transport, and the data its sole purpose was to basically present that information to the public. Various different local authorities could just perform data analysis on it, just EDA. The data isn't in a necessarily good format for machine learning. So having a live model where people can upload batch, someone from a member of the public could upload a batch sample of data to a model that we could have deployed. That wouldn't necessarily work because it's not, at the moment, we're having difficulty trying to identify any patterns. Well, the machine learning model is. So, a public deployment of a machine learning model may not be the answer, but what might be the answer, if we can make any sort of progress on a binary classification model to sort of be able to separate the serious and the fatal, the use of the machine learning model would generally be internal. So it would be, if a local authority hired a data science team, the model would be used internally. It wouldn't be for public, and that's absolutely fine. That is absolutely fine. We can, a lot of the time it is like that. Like when I was in my previous role, I built a machine learning model that would map contracts based on keywords, it was sort of like a text classification model. And now that wouldn't work publicly because it was designed around internal data structure. And that isn't, it wasn't accessible to the public. But I could drive decisions and and help customers and account managers make business decisions using internal data with an internal model. So based on what our findings at the moment, that looks like the way it's going to go. It wouldn't be a publicly deployed model. It would be something that a local authority would use internally with their own data. That's fine. The next step I discussed as well would be to create a dashboard. And I suggested Streamlit, but I was having a little think about it, over the past couple of days. Since we're not deploying a publicly available machine learning model, we wouldn't necessarily need a Streamlit dashboard, only because, Streamlit dashboard, it's a good way to go because it also imparts knowledge to you of how to build one. And that is very valuable. But because our analysis and the machine learning models that we have built will be basically providing results which a client would retrospectively making decisions on, we could simply create a website and show our analysis. We can show the time series analysis and what we predict, what the future is going to be like, the geospatial map. I already uploaded that to my personal website so people could take a look. So that is also an option for deployment. I think I'm going to gather the notebooks that we've did and extract all the information from them and present it on my personal website and just see how that goes. And of course, you guys are very much welcome to link that into your resumes or post it on LinkedIn and talk about what you've contributed. And I think, it would be a good space for documentation as well. What we need to do, what I'll do is it's a final presentation as well. So either this Saturday or next Saturday, there's no rush on this because there's still a couple of little things that we have to iron out. We can, what I want to do is make a recording where each lead presents their work back to the group. And what we'll have is a nice video, which I can upload to YouTube and LinkedIn and onto the LinkedIn Omdena Liverpool chapter, which is the sort of final product presentation. And that will be able to be also published by Omdena itself. So let's just see what happens on Saturday. And a couple of people, I'll build a rudimentary website. If anyone's done anything on Streamlit, let's talk about that Saturday, and we will also incorporate that. And then the following Saturday, we won't have next week. We won't have a midweek meeting. Let's just work on the presentations. What I'll do, I'll send the same template that I used for our kickoff meeting. And if everyone could build a couple of slides explaining what they did in, what they did overall, it doesn't have to be really into, preferably make it, so you could explain it to a 5-year-old. Let's make it simple, throw a few nice graphics in there, maybe a couple of code examples that you particularly found interesting. And also, so I'm asking about 4 slides each for each lead, each co-lead and whatnot. And also, I think, after each sort of section, it'd be important to list what you've learned, what was difficult, what you found easy, and just some general feedback on how you think you performed and how the group performed all together. That, maybe shout out some people that really helped you. Just so we can, the final presentation, it'll be an hour, maybe 2 hours tops. And we can get some really nice video, which obviously, again, you can share on your resume, you can share it on LinkedIn, and it'll be on the YouTube channel, and you can always refer back to that. And it's a good place to show that you've done some real good, credible work. So let's do that. Not this Saturday, next Saturday, and I'll book something in, and we can brag about ourselves. We can show the world what we've done so far. In the meantime, if anyone's working on the Streamlit app, we'll present some of them bits on Saturday, and I'll also put a rudimentary website together, just with a couple of extracts from a couple of insights and a couple of extracts from from the notebooks that everyone shared in the Slack. And also I'll move them workbooks into the GitHub as well. But it would be an idea for you to put those, because the Omdena GitHub is private, so it would be an idea as well to basically make a copy of the Omdena GitHub into your own personal one, again for your own benefit. You know, you've got a record and you've got a portfolio. This is very much a portfolio project, even though it didn't go as planned. Even though we may not be able to offer a public solution, we are still able to offer a solution with plenty of insights in a private, you know, sort of for a client, basically, who may be a local authority. We can still, you know, provide insights for them to make the appropriate business decisions, and that's just as important. And that is, you know, probably more a truer reflection of real life. You know, models that get built in a private organization generally don't get built for public use. So, you know, it's a perfect example of how it works in industry as well. So, you know, even though when it's not expected, it's still very beneficial to a client. So I think that's what we'll do, and I'll sort of solidify that in the Slack chat with the plan. I'll get something together for Saturday in terms of like a nice little website, you know, just to and of course the documentation to go with it as well. So yeah, please, you know, get involved in that. If you're trying to build a stream app, I shared the documentation, which is fantastic, into the Slack channel as well. So it'll definitely be worth trying to implement something, even if we don't use it. It's for your own benefit, because you'll be definitely, you know, as you learn more about data science, you go on more courses and stuff. A lot of them use Stream App to show how the model works. Retton's one is a prime example of that. He did a fantastic one, which is hosted on Heroku. I think that's how it's pronounced, Heroku. And you know, you can make predictions by sliding certain features and setting, you know, random values. It'll make a prediction. You know, it's a good demonstration of your knowledge more than anything. So yeah, okay, let me just get rid of the participants. Always, you've tried 7 or 8 different methods to make the model predictions more precise, but nothing seems to work. Would you mind sharing your screen, Always, and just showing us what you've done?
Yes.
Okay, I'll go off camera.
So these are all most of the methods we discussed in the previous meeting: undersampling, oversampling, easy ensembler, smart. So after that, I tried to do the hyperparameter tuning, grid search CV, to search for the best parameters and hope that it would make some improvements to the model. And these are the best parameters for a random forest classifier. And I tried to train the model using these parameters, but the results still remain the same: the precision and recall, trade-off, and everything. So then I also tried to do undersampling on these best parameters, but still nothing too good to go on. After that, I tried this. This method was I found it on the machine learning mastery website, and what this does is that these are the the serious and fatal class weights. So what this does is that it emphasizes on the minority class by changing the weights, and it did show a little bit of improvement in the ROC curve and precision recall curve, but the overall results were still not good. And I also tried to train a support vector machine algorithm, and it was it was really bad. So I didn't bother anymore with it. I've also been working on the Streamlit dashboard. Let me show you. So what I have in mind for this dashboard is this. The I'm trying to. These are this number of one accidents. This one actually represents the serious accidents. It shows one here because I have used the encoded data frame. So in that data frame, the serious accidents are represented by one and the fatal are. So if I change, where is it? Um, Give me a second. Yeah. So if I change the severity status from 1 to 2, like from serious to fatal, and then save it, yeah, it returns the number of fatal accidents and the number of casualties in fatal accidents. And also, if I change the year, let's say 2006, and then save it. So it returns the fatal accidents in the year 2006 and the casualties in the. What I'm trying to achieve with this is that I'm trying to to plot the accidents occurrences on this map, and I'm trying to build actually a drop down menu here in which a user will be able to select which year, select the year and get the numbers of accidents and casualties for it. And I am also planning to build a menu on this side, so it will have all the pages like you told me in the Slack channel that one will be for visualizing, and so that's
Yeah.
my plan for first. But if you want to switch to a website and want to move on with that, then it's fine. It's totally okay. We can do that as well.
Well, you've
So
made a lot of progress on your Streamlit app, so I'm happy to continue with the Streamlit app. How are you finding the documentation for Streamlit?
yeah, I'm using Streamlit documentation and also different tutorials on YouTube, and
Yeah,
so yeah.
yeah,
So
that's really good work. Always, you've really done a stellar job there. As you say, if you know can implement a couple of drop downs so people can select it, it's absolutely fantastic, and it sort of kills two birds with one stone really, because you've got the geospatial part of it, and you've also got like information about the various different you know, the amount of accidents and the amount of casualties associated with them accidents. So it's really good work. I'm very impressed. You should be really proud of yourself. Yeah, we can continue with that. You know, just do what you can, you know, what you can, and you know, even this so far is good enough to like present and say this is what we're working on.
yeah,
Once we fine tune it and include the EDA analysis and that, I mean, the EDA part of, you know, the page, it'll be a static page. It'll just have a couple of the um, key sort of charts and plots that we've created, with maybe a couple of bullet points of narrative as we've already got in the notebooks. So all the work's there. It just has to be compiled into a nice dashboard. But yeah, absolutely fantastic work. Kevin has asked the question, can you explain why the results are not good? What we,
y-
yeah, go on. Oh
go
wait,
on, go on.
I'll let you explain. Go on, go on. It's your work.
And so the results are not good. It's let me show him the, because is as you can see here, the number of serious and fatal accidents are the counts are very imbalanced. So the model does not get enough entries for the fatal accidents to be able to find a pattern for it and make predictions on it. So we have tried different methods to overcome this by doing undersampling. If you can see, it's before the undersampling. These are the number of serious and fatal accidents, and after the undersampling, you can see that the classes are balanced. But every balance technique has some negative impact on the model. So we've tried different techniques, and in each technique you can see that the the classes have been balanced, but actually uh, it generates new data points which does not properly reflect the original pattern of the class. So the model is unable to make predictions on the new data points. So yeah, that's the problem we are facing
Yeah,
right now.
and also as well, if you do some rudimentary EDA on the serious and fatal accidents, there's very little, if anything at all, that separates them definitively. I think it's a very grey area of when a serious accident becomes a fatal one. It seems to have very, very similar, if not exactly the same, situations. There's no pattern between the two. There's no, clear line between the two, and that will inherently, create an issue, because it'll be hard for a model to identify the difference between the two. And there's nothing that indicates in the data the difference between a serious and a fatal accident. I imagine this kind of information is very much individual case dependent. Do you know what I mean? Like a serious, if someone could have a serious accident and then later die in hospital from their injuries, and then gets classed as a fatal accident, it's like, it's very circumstantial. I imagine some of it even depends on the kind of people that are involved in the accidents. Say if you've got someone who's like a 90-year-old who's quite frail anyway and gets into a serious accident, the situation the accident's happened in would be serious for someone who is, say, 25 with no health issues, but it'd be fatal for the 90-year-old. But that isn't captured in the data. And that's what the issue is between trying to define the serious and the fatal. It may involve features that aren't included in our data set and which couldn't be captured in the data set. So we would, it's a very difficult, it's the data isn't telling us enough of the story, because it can't capture every nuance in life, unfortunately. However, we've still got plenty of insights about the data. We can tell where most of the serious accidents happen. We can tell where most of the fatal accidents happen. We just can't predict. We couldn't productionize a model which would be able to determine between the two, which isn't necessarily a problem. That's what happens in real life. Sometimes machine learning models aren't the answer, but what they can certainly do is give us insights to make decisions, and that's what's most important. So yeah, Kevin, we did mention that in the previous call. If this was a real life situation and we were working on this project for a client, the data and how it's recorded isn't necessarily, it's good for EDA, it's good for that kind of thing, but it's not necessarily good for machine learning modeling. So it would then be up to like the data engineers to liaise with the client to improve the raw data, which could be solutionized. However, this is just data that we've pulled from the Department of Transport. That isn't an option. But this sort of highlights the problems and difficulties you do have in real life. Not all data is created equally, and this will be an ongoing project between yourself and the client. and you'd have to come up to some sort of agreement of what kind of data needs to be collected for you to build a successful machine learning model. Because the data as is isn't that great. But yeah, that, you know, that's part of the difficulty. And you know, we've tried a million different things. Oasis is pretty much taken the book of machine learning and thrown it at the data, and isn't able to pull anything of significant value. And you know, that happens sometimes, and that's it's good to learn that, because that'll set, you know, if you get a role in data science, machine learning, or whatever, you 100% will be faced with this kind of issue, and you would have to be, you know, have a close relationship with the data engineers to, you know, to have them make that data more usable for you. But as I say, you know, if we were working with a real life client, all the insights that we've pulled out of, you know, even the interesting ones like the year, the age of the cars and things like that, all that is very valuable, and the client will be able to make data-driven decisions based on our analysis. So again, it is, you know, we've done fantastically well. There's been some things that I never expected that we'd pull out of this data. So what we can do, we can definitely document everything we've done. Michael's notebook and Oasis notebook, in terms of the modeling, we can document that through our solutions. Say, you know, this is what we tried. We've tried SMOTE. We can, you know, talk a bit about SMOTE, and we can provide, you know, a story of what we've done and how we did it and what the results were. And that's fine. If it didn't go, you know, if it didn't, you know, it wasn't the best solution we could do, we couldn't build a solution out of it, and that's absolutely fine. But it's what we're getting out of this is the learning experience. It doesn't matter if the solution is a success or a failure. It's the learning part of it. And now everyone who has participated in our group understands that real life data is an absolute monster, and there's no easy solution. Yeah, it's great working on all these courses that give you a nice clean data with, you know, obvious patterns in it and easy sort of targets and very, you know, correlated features and whatnot. But you know, 99% of the time in real life, you don't get data that easy. You have to really drill down on it for months and months before you can even think about building a model. So, you know, that is the learning experience, and I think we've done a cracking job. But yeah, always that was that Streamlit app is, you know, you've made fantastic progress on that. I'm really pleased, and you know, keep working on that. And on Saturday, we'll present more of the progress on what you've done. Michael couldn't make the meeting. He's still in work at the moment, which is fair enough, but I'm sure he'll have some insights as well on the Saturday. And then the next Saturday, that's when we'll do our final presentations. And so I'll post a little roadmap in the Slack. If everyone who's had, you know, who's made a significant contribution, the leads on the various tasks, if you could create between 2-3 slides, just demonstrating what you've done, what you found interesting, what you've learned, any sort of difficulties, and we will be able to put that into a you know, a video project, and we'll be able to upload that. A video project, I mean, like a video summary of the whole project, and you know, what we've done. I think the most important part of it as well is what you've learned, what you found difficult, and whatnot. We can talk about that and present it to other people who are part of the Omdena community. That will be great. And then obviously Oasis can present his Streamlit app as well, and that will give everyone, you know, the basics of what we found and any other any other insights, and of course the documentation of, you know, what the project looked like from day one till the very end. But yeah, I think everyone has done an absolutely fantastic job. We've had, you know, I've worked on other Omdena projects before where it seems, you know, by about 2 weeks in, there's probably only about 5 people who are responsible for all the work. But in this group, we've had more than, you know, we've had about 30 people contributing, you know, not just creating notebooks, but offering suggestions, offering help, talking about and supporting others as well. And it's been really good to see. It's probably the most active Omdena project I've seen in terms of numbers. And you know, I was very surprised how well everyone's worked, even though the project was designed at beginners. Usually the beginners are quite sort of introvert because they're not entirely sure, but I think most of the beginners on our on our particular project have thrown themselves in to the deep end, and that's the best way to do it. It's jump in at the deep end and find your way out, basically. And that's what we've seen. And we've had some great work because of it. So well done, everyone. Okay, so that's cool. Always fantastic work again. So yeah, Kevin, what do you say? I agree. I've been trying to find something in the data set to differentiate between the two. Car was speeding may not help us highlight. Yeah. So that's the problem that we've got. It's very difficult to define when, you know, all fatal accidents will be serious. So they'll have the same recipe. So it's very difficult to separate the two. And that's what we've seen. That is what we've seen. So yeah, it has been a problem, and in real life we would, as I said, we would go back to the local authority or whoever's collecting the data and say that's not, you know, we need better data. Basically, if we want a machine learning solution, we need better data. But yeah, fantastic work, everyone. Has anyone got any questions at all, or have they got anything to share with the group?
Hello.
Oh, hello.
Okay. Can I share what I was able to do?
Yep, of course. Yeah, of course. Let me just turn my camera off. Share your screen. We've got 5 minutes left on this call, so get started, and it'll just I'll just reset it when it's timed out.
Okay. Okay. Hold on. Okay. Can you see it? Can everyone see it?
Yep.
Okay. This has already been done by Oasis and Michael. This part. So I used regression. It was really, the result was really bad. But my
I think, are you sharing a notebook there? It's
yes.
just because we can only see the Zoom meeting web page, your internet browser. I think it might be the wrong screen.
Oh, okay. Okay. Hold on. Yeah. Can you see it now?
Yep, see it now. Thank you.
Oh, okay. So I used logistic regression. The result was really poor. This place has already been covered, so I just go straight to what I felt like. Okay, so I tried using feature reduction. So I used the features from XGBoost and CatBoost to perform the modeling. So Sharp didn't work on it, but I still used Boruta to do it. Then from the XGBoost here, from the XGBoost, I did some grid search, and the result wasn't really fantastic. I was able to get for the XGBoost, the precision was 0.85, that's 6 for the serious and the fatal. So I tried again for random search for XGBoost. The result was, this one wasn't okay. So again, I moved to Bayesian, but it didn't work, but I'll still work on that one. Then for CatBoost, for hyperparameter tuning, I tried doing it, but at the end of the day, the insight I got from here is that the grid search for CatBoost and XGBoost arrived at similar result for this thing I did using the feature reduction from CatBoost. That's all for now.
Yeah, that's cool. Well, you know, CatBoost and XGBoost are quite similar in terms of how they work. And you know, XGBoost is like the sort of king of tabular data. But again, we hit the issue with the unbalanced data sets, and also unbalanced target, and also the fact that it's having great difficulty defining the serious and the fatal. So that, yeah, it's the same sort of issues, but that's good work. And the use of the grid search as well, it's good, because, you know, the hyperparameter tuning can be a nightmare if you do it manually. Take a lot of time. So doing it automatically is fantastic. Also ML platforms as well, such as H2O and PyCaret as well. It'd be interesting. I mean, you know, I'm not saying definitely do, but H2O, you can import it into your notebooks or your Google Colab, and use the API, and you can get the AutoML to basically train up to, I think it's up to 25 different models using all the parameters that they have, and see what the out results would be. I'd be interested.
Okay.
Usually AutoML is better than what a human can do themselves, and especially Google AutoML as well. It's got to a point now in industry where you benchmark your model on XGBoost and then use AutoML to actually create a solution. So if anyone's got time, I'll share the link in the Slack channel about H2O. Very easy to implement. In fact, I'll share a notebook that I've used H2O ML for. Just copy the code and adjust it for our purposes, because that would be very interesting. I'm just going to reset the call only because we've got 20 seconds left. So I'll see everyone in a moment. Okay. Right, what I'll do, I'll just go through. Let me just go to my GitHub. I've got it uploaded there. I've got it. I had it on Google Colab, but I think it was through my old Works account. I need to verify my login, and I'll go through the AutoML. I won't be able to run it only because I'll have to download all the data again, but I've saved it so you can see what the performance were and whatnot. So give me 1 second, right? I'll share my screen. This one. Okay. So this was, I actually built this for a workshop I was doing for Omdena, Algeria, and it's on water potability, and it's synthetic data, and it has the same issues as the data that we're using. It doesn't really make sense, and that was the point. So where are we? It doesn't look like I haven't run it actually. So, you know, I put all like the sort of different models and things like that, logistic regression, because it was a binary classification task. There's me hyperparameter grid for the best model, which was the XGB classifier, and it, you know, it printed out the test performance, the classification report, the graphs confusion matrix and whatnot. I used a voting classifier on it, and I also used the auto ML, and I'll share this into Slack. It takes quite a while to run, and it's quite computationally heavy. So I would suggest using it in Google Colab, or use the new Kaggle notebook system, because they've upgraded it recently as well, and I believe it's a lot faster than Google Colab's one at the moment. So all it is, you'd install the H2O, and the only difference is really you import the data to H2O API using the import file, and it's, you know, wherever it is saved locally. It does all the cleaning for you. It does all the pre-processing for you. What I've did here is basically make the target variable a categorical one, which is your binary classification. But the only difference is you use as factor, which is built into the H2O platform. The documentation again for H2O, unbelievable. It's really good to give you all the examples. So this is all you do. You load a function which is inbuilt. The max runtime, I give it 500 seconds only because, which is about 8 minutes, which we were doing it live on a call. The max models is how many models you can, you can look at. So it'll get 25 different models, and it'll run the data through all of them and give you the best one. You can balance the classes as well. So that's sort of like the stratify option in the train test split package from scikit-learn. And you fit it to your data, and it'll print out it's a shame that I haven't, because I shared this for the students to run it themselves, so I didn't share any of the answers. But what turned out to be the best model was the deep learning grid AutoML app, and it gives you when you check the model statistics and your best performance, it gives you every single hyperparameter, and you can save the model and load it again to test to make predictions on. Very easy to do, and it gives you the explain model as well. And when you print out when you load the explain model, it gives you the partial dependence interpretation. It gives you the SHAP interpretation as well, so you can see how the models come to its decisions and why this one is the strongest model. So I'll share this into the Slack channel and just amend it to look at our data and see how it performs, see if it can perform better than what we've done manually. It'd be quite an interesting experiment, and it shouldn't take you too long either, because it's fairly self-explanatory. The documentation's there, information about the evaluation, and I've also included the parameter appendix as well. So it talks about what you can include in this part here. I've just done it quite simply, but there's plenty more you can experiment with. So if anyone's got time, go ahead and try that, and take a look at Michael's and Oasis notebooks, see what their best scores are, and see if you can beat them. So yeah, that'll be a good learning one, and it'll show you the power of AutoML as well. There's others, there's like PyCaret and things like that, but I think H2O is probably the best one to start off with, because it's dead easy to implement, very easy. It's quick, and the documentation is very clear and fantastic as well. So yeah, I'd give it a go. I'll share that into the Slack channel once we're done here. Okay, so let's get rid of that. I'll stop sharing my screen. There we go, done. Okay, so let me just take a look. Yeah, PyCaret and H2O, same sort of thing. I just prefer H2O simply because the documentation is fantastic. So, if you're using it for the first time, it's probably a bit easier, but both of them are great. Yeah, I won't necessarily be applying for Omdena projects to work on, only because my time will be taken up with other things. Now, I will, as being in terms of being a chapter lead in Omdena, I'll be running a new task probably once every 3 months. So probably won't be running another one until the new year, maybe March, maybe February, March or something. Because I'm the lead, I can take a little bit more of a step back, because the purpose of it is to have the participants learn and do the work kind of thing. But working on a project myself, I'll probably not do that for a while, just until I understand what I need to do in the future. It's hard to plan, because the way Capgemini works, it's very much project based. So I could be working with a client for 6 months to develop a solution with another team, and it's pretty much round the clock working kind of thing, and I probably won't have much free time to do anything else. Yeah, the Omdena research projects, they're like sponsored projects, where this one has been very much about, you know, to give the opportunity to beginners to either start or enhance their learning and, you know, and development. The research projects are ones that are basically funded by real companies who work in collaboration with Omdena, and you know, they might have a product that they need to enhance. There was one I was going to work on but didn't have the time, and that was one with Light BC. Me and Salman signed up for that one, and they have a product called a Hemiscope, and it takes pictures of your blood capillaries and blood flow and things. And what they wanted to do was use computer vision to identify various different cells in the pictures, and also monitor things like blood speed going through the capillaries and stuff. So it was like motion detecting and motion tracking and things like that. And that one is a sponsored one because the company's approached Omdena. I can reach in the Liverpool chapter, I can reach out to local companies and also get them on board and say, listen, if you've got, you know, if you've got data and you need to, you know, you want to you need a solution for whatever it is, you know, we can help out on that. And I would then recruit for that, and that would be the sponsored one. But they are much more complex, and, you know, I suppose they're for people who are a bit more seasoned in machine learning and data analytics. I'd probably do about 4 to 5 normal Omdena local chapter projects before I would reach out and get involved in a high level one, only because they are quite complex. They don't really use much Git. Like, a lot of it is, you know, you'd have to access the data from their system, so you have to understand, you know, Git, SQL, and all that kind of thing. So it's a bit more complex, but I fully recommend them. They carry more weighting as well. You know, you're obviously you know, if you complete one of them and you get your certificate, you know, your certificate of completion and whatnot, you know, it has a lot more weight because it is a sponsored project. And I do believe it's probably the place where what leads to a lot more job opportunities. So yeah, generally the local chapters are for beginners, and just to build on knowledge, and you know, develop a much more thorough in-depth, and also give the opportunity to work in a team as well. You know, it's one thing having all the knowledge, but if you're not a good team player, you know, you're not going to go far, basically. So it gives you that sort of environment where you can experiment, you can learn, and you can make errors that won't, you know, affect a real life company kind of thing. So yeah, exactly, Kevin, and help and teach others as well. The best way to solidify your understanding of something is to teach it to someone else. Definitely. That's what I've been trying to do as well. You know, when I first started out, I would try and teach other people, other colleagues, about what I'm doing. And in that way, I would identify, you know, if someone asked a question that I didn't know the answer to, I knew I had to work on that particular part. And that's what, you know, that's why Omdena is such a great platform, because you can ask those questions. You can be, you know, there's nothing wrong with someone asking you a question you don't know the answer to, because, you know, that's just part of the learning journey. But if you were in the industry and it's a dog-eat-dog world, if you don't know someone might criticize you, and it might knock your confidence. This is the safe space where we can do them kind of things. Thank you very much. Appreciate that. It's been a long time coming. I've known about the new job for a good while now. It's just and I started on Halloween this Monday, so it's only my 3rd day in. But it's been fantastic so far. Just can't wait to get stuck into some projects. Don't know what I'm going to do yet though, but we'll see. I'm sure I'll keep it up to date on LinkedIn. But anyway, I'll tell you what, let's call it quits. What I'll do from this point, the plan of action. Oasis is going to work on the Streamlit app. He's done fantastically well so far, and it looks absolutely great. We can, you know, focus our attention to that. If you've made a significant contribution to any of the groups, I'm going to share the template for the kickoff meeting. If you could make between 2 to 4 slides about what you've done, any sort of code examples or any interesting plots, any observations you've made, and basically a summary of what you've learned, what's been the most valuable lesson you've learned and what you've struggled with, and any sort of, is that, have you identified a gap in your knowledge that you'd like to further develop? Include that kind of thing, a bit of self-reflection, and of course a bit of self congratulations as well. If you struggled with something before you jumped on this project and now you've sort of learned it and you're confident in it, congratulate yourself, tell everyone else, brag about it, and so we can present that then, not this Saturday, the following Saturday, and that will be our sort of like final presentation, and we can then record that meeting and we can post that on YouTube, and Omdena will share it for us about the whole project. We can talk about what insights we've made and how that will be useful. Always can demonstrate and show his Streamlit app as well as the work that he's done, and it's the same with everyone else who's created notebooks as well. I think what we'll do, we'll give everyone maybe say 10 minutes, we probably won't even take that, between 5 and 10 minutes presentation time. And what I'll do, I'll put like a little itinerary, and we, just to keep it managed so we don't overrun and make a massive 4-hour video that no one will watch. We'll keep it quite tight and quite effective. And I think that will be, at the same time, it'll be the same time, definitely. That's not a problem. Because it's a Saturday as well, there's no issue there at all. So we won't have a midweek meeting next week. It'll just give people time to put together a couple of slides, and we can figure out a structure to that meeting and that final presentation. But yeah, that's what we'll do moving forward. I'll post, I'm going to upload Saturday's meeting as well. Again, I've had issues editing the videos for some reason. My computer just decided it doesn't like the video editing software anymore and crashes all the time, but it's done now and I'll upload it. And again, I'll upload this video as well as soon as I can. And yeah, we'll go from there. I'll post more information about this, the next couple of steps, in the Slack channel, just so everyone's on board. But well done everyone, you've done really well, and we've done some great work, despite it not going the way we would like it to go, but that's the beauty of life, isn't it? Okay, everyone have a good day, and I will catch up with you shortly, and I'll see you on Saturday. Thanks very much, everyone.